Good morning, everyone. I'm Devlin, a senior analyst at the Energia Group. We're a large, vertically integrated utility working in the Irish market, a market that has undergone significant change over the last year, and is the focus of my presentation today. Key background about our market itself: we're thermal generation dominated, predominantly gas-fired units, but we also have a significantly high penetration of renewable energy, specifically onshore wind, which is set to reach parity on a megawatt installed basis this year, and will continue to increase as we progress towards achieving our 2020 and 2030 climate goals. Transmission system peak demand this year sitting around 7 gigawatts, and as we go to 2028, that's set to increase to around 9 gigawatts, driven mainly by the development and build-out of data centres. So we're a pretty small market with loads of wind, and that means it's a pretty interesting place to work. The actual market itself, we're two jurisdictions, so it covers the Republic of Ireland and Northern Ireland. It's two currencies, sterling and euros, but most importantly, we operate as a single electricity market. So the first iteration of this market design went live in 2007, and as of the 1st of October 2018, we transitioned to our imaginatively titled Integrated Single Electricity Market. So why did we have to change? Well, we didn't just wake up one day and figure out, we're pretty bored, we want a new market. Our old market wasn't EU target model compliant. So it was a centralised pool, and we bought and sold to the pool. There was limited opportunities for trade. There was no such thing as balanced responsibility. It just didn't exist. And there was suboptimal allocation of physical interconnector capacity. With ISEM, we are now target model compliant. We have multiple energy markets covering at different timeframes. We have a new capacity market that is no longer availability based. And we have a high degree of ex-ante coupling with our friends in Great Britain, due to the fact of our participation in the day-ahead market and the Euphonia algorithm, which has the added bonus of much more efficient scheduling of our interconnectors. The three main drivers for this market design change were increased competition, lower prices, and increased security of supply. And the jury's still out on all three of those. I'm going to focus mainly on the energy markets, and it's my job to derive trading strategies for our gas-fired generators, so I'm going to come at this from a thermal generation perspective. So we have our main energy markets, the day-ahead market, Euphonia, 11 a.m. the day before, prices and volumes and interconnector flows. But importantly, the day-ahead market in Ireland is the exclusive route to physical scheduling. We then head on to the intraday markets, manage forecast errors or unit trips. We have three separate intraday auctions covering 24, 12, and 6-hour periods in 30-minute trading blocks. We also have parallel opening of the intraday continuous platform, and this just enables us to manage our errors before heading into the balancing market. So this is the real-time market. This is when the TSO takes over and we transition from an energy market to a power system, and it's the primary force for implementing balanced responsibility. This is what our first year looks like. When you look at the macro levels, we can see that the day-ahead market is basically the reference for every other ex-ante market, with the balancing market exhibiting significant volatility depending on this underlying system conditions. And I'll touch more on that later in this presentation. But the market design change was a big deal, mainly because it fundamentally changed our company and every other market participant's relationship with the energy market and how we interacted with it. It's a whole new world for market participants, and we've had to learn about risk pretty quickly. We're a bit different in the fact that the ISEM is a unit-based market, much like our Iberian friends. And importantly, the day-ahead auction is extremely important for a thermal unit-based market because it's the main route to market, since it's got the highest liquidity of all the ex-ante auctions. But it's the day-ahead market is the only ex-ante market that it has the appropriate order types for a thermal generator to ensure its cost recovery. Our old market had explicit representation of things like start costs, no load costs, and technical characteristics such as min-off and min-on times. But these constraints aren't represented directly in the order types in the day-ahead market and any other market in Europe. So we've had to internalize our cost base and how we interact with the market, and this requires us to rely quite heavily on the complex order functionality in Euphemia, and it's extremely important that that complex order format is there for us to use. Otherwise, we cannot manage our pricing and scheduling risk. But what actually matters in the day-ahead stage in Ireland? Well, on a high level, looking at each month since go live, we can see it's very much a tale of two seasons. Seasonality is a big driver in our price profiles, with two distinct summer and winter profiles emerging quite clearly. But when it comes to hour-to-hour pricing, what matters? Well, we have lots of wind, but surprisingly, on an hour-by-hour basis, the wind doesn't really have that much of an impact on the day-ahead price for each clearing period. Forecast demand is a bigger driver of the price. That's not surprising because it enables us to figure out how far up or down in the merit order we have to go. But it's not until you combine both forecasted wind and forecasted demand to derive the net demand figure. So basically you get your forecast demand, subtract off your forecast wind, and whatever's left is what's left for thermal units to compete for in the market. And that's when we see some real strong correlation coming out of the data. That's backed up by a relatively simple regression tree predictor here, and it says that net demand is a big deal for price formation in the Irish market, followed by yesterday's price and the overall total demand. It's not entirely surprising. I'm not going to blow anybody away with that conclusion, but because the day-ahead market's unconstrained, we can have as much wind as we want. It's basically just a supply and demand curve with no real semblance of an energy system. We have high installed capacities of wind, like I said, and the dam is the highest the highest liquidity of the ex-ante auctions. In September, about 87% of the traded volume went through the dam alone. But it's not just about system fundamentals. Competitors now have strategies. In our old market, it was very pedestrian. We had very strict rules. We could only bid in our short-run marginal cost. There was no competition, really. Now, there are no rules in the ex-ante markets. We can do whatever we want. Anyone can do whatever they want. And we can see here that there's a huge difference in competitor strategies and their behaviours. We can see on the graph on the left, that's assetless units. Assetless units didn't really exist in our previous market design. And you can see here that their behaviour varies. Some take a more scattergun approach than others. And compare that to the other plot here, which is basically just our thermal units. They're pretty predictable and tend to bid in their short-run marginal cost over the long term. And it's this change in behaviour that we've had to get used to pretty quickly. The reason for it is the objective function of market participants now is a big impact. Assetless units are there to speculate and make money. Thermal units are there to recover their cost and hopefully make some money. But in a unit-based ex-ante market, assetless units are at a distinct advantage over thermal generation because they have no technical constraints to adhere to. As part of the market rules, me as a gas generator, I have to submit a physically feasible PN, a physical feasible position. I have to be able to generate the position that I clear. But other market participants can just take positions and drop in and out whenever the price is right. So I'm going to go straight to the balancing market because this is the heart and the home of volatility in the Irish power sector. It is the balancing market is the big scary one that everyone's terrified of because of the volatility. Because we don't have very much liquidity in our intraday auctions, if I get a position in the day-ahead market and my unit trips, then I'm in for a long night potentially. So what happens is after the ex-ante markets finish, we sum up all our ex-ante trades and generate what's called a final physical notification. It's just a summation of all our trades that has to be physically feasible. The TSO, we submit those to the TSO. The TSO then tries to turn that energy system turns that energy market into a real-time power system. And to do that, they move people away from their FPNs. So I submit my FPN and I get dispatched above that level. That's an accepted offer, and it's priced on my incremental cost curve. And if I get decked below that FPN level, that's an accepted bid, and it's priced at my decremental cost curve. And then when we sum up all the balancing actions, all these accepted offers and accepted bids, we get the quantity that's called the net imbalance volume, which dictates how short or long the system is and what the TSO has to do to resolve any imbalances. But it's extremely important in the market to define what a balancing action is. Some are for resolving energy imbalances, so making sure there's enough supply to meet demand. but others are for ensuring power system security. For example, there has to be 3 units on load in Northern Ireland at any one time. Only 2 of those units may achieve a position in the day ahead, so the TSO has to start this unit and deck off other units, maybe in the Republic of Ireland. So we've got this distinction between energy and non-energy actions because our market design states that only energy actions are eligible to set the price. But as a reminder, the Irish power system is very small. We have lots of wind, so we have a lot of volatility inherently in our dispatch. Thermal units have a very high min-gen compared to the demand that we see in the market, so the very lumpy profile, and makes the unit commitment problem that bit more difficult to solve. But we're also very poorly interconnected, so we only have around 10% of our installed capacity as interconnection. So the TSO is operating in a very highly constrained system, and when we mix all these factors together, it has the potential to create extreme volatility when it comes to the balancing market. Case in point, a day last January, the system was actually long, so the NIV was negative. The net imbalance volume was negative, but the megawatts were in the wrong place. There was a transmission constraint between the Republic of Ireland and Northern Ireland, and this caused, and the lights were about to go out in Northern Ireland. The TSO had a dispatch on some very expensive peaking plant, and they fed through and set the price. And this is the reality of the market that we are now operating in. And that happened when the system was long. But generally, there's a relatively decent logical trend when it comes to evaluating the correlation between the net imbalance volume and imbalance prices in the Irish market. I want to draw your attention to the orange dots in this graph. So this is the 30-minute imbalance price. This is what we're actually settled on, and the primary embodiment of balance responsibility. So we see here, at a high level, when the system gets short, so the NIV increases, prices increase. When the system's long, prices decrease. But I now want to turn your attention to the blue dots in this graph. The 30-minute imbalance price is made up of the simple average of the 6 5-minute imbalance prices that happen in that trading period. We've attempted to design a balancing market, but what I think we've actually done is create the world's first truly random number generator. The volatility speaks for itself on this graph. And just a little bit more on that. So we've got the change in net imbalance volume per 5-minute period versus the change in price per 5-minute period. And I want you to look at inside this box that I've drawn on the y-axis. We see here a change in 5 megawatt hours in the net imbalance volume. So we're seeing basically the system changing and swinging around by maybe 60 megawatts. But that has the potential to have accompanied by a price swing of plus or minus 500 euros per megawatt hour from one single 5-minute period to the next. And that's how the Irish market works. The volatility is introduced because of the need to differentiate between an energy and a non-energy action. How we do that and what the TSO balancing actions are on real time are the main drivers of this volatility, and it's not necessarily market participants' bidding behavior that achieves that. And it's this volatility it's a constant concern, it's a constant challenge, and it's something we're getting to grips with, and we're building our understanding every day. Balance responsibility is pretty motivational. It can go spectacularly wrong or spectacularly right, depending on what side of the market you're on. But I think it's important to note that just relying on the net imbalance volume as a signal for what the balancing market price is going to do is not necessarily going to tell you the whole story. You need a high level of subject matter expertise and understanding of how the TSO runs the system and how they react to certain scenarios. But more generally, higher level challenges across the entire market is that we're constantly working in an information imbalance. We get the results of the auction after it happens, obviously, but we don't get the detailed bidding behaviors on the bid file until after the trading day. So you've basically missed 2 sets of auctions by the time you can act on the information you have. And that means oftentimes the window of opportunity for a trade has gone before the time we actually discover it. Intraday liquidity is a big issue and will continue to be because there are no thermal unit friendly order types at the intraday stages. So we basically have one shot at getting a position as a thermal unit, and that's in the day ahead auction. If we do not clear in that auction, then you just basically hope that the TSO needs you in real time and they dispatch you on. But I suppose a bigger concern would be the sheer volume of data that we now have to parse and analyse and try and distill down into information that we can act on in a a time frame where it's still valid. We get balancing market prices every 5 minutes. We get schedules for every unit on the system. So it's trying to make sure that we have the right systems in place to handle all this data and turn it into actionable insights. And the final big challenge, I suppose, is the market system limitations. We got in a bit of a rush to try and get everything in. The market operator had to de-scope with a few things, and their go-live position wasn't perhaps optimal. So we have a lot of underlying issues from that decision to go live when we did. For example, basically every day for the first 9 months of the market has to be repriced. There are still defects in market systems, and there are still defects in the trading and settlement code, so basically the rule book. So we're still trying to work through all of that uncertainty, and that will be the gift that keeps on giving for a few more years. But all in all, it's been a very enjoyable journey, aligning ourselves with the EU target model. It's been a fascinating learning experience, and we look forward to seeing what the next year of ISAM has in store for us as market participants. So thank you very much for your attention, and gladly take any questions.
Yeah? Okay. Thank you, Joe. Thank you. Really interesting. The increasing volatility in the balancing market and how to deal with it is really a hot topic in Ireland. So does anyone have any questions? Yeah?
Petter Hansen from Refinitiv. As a producer, what are your opportunities in the balancing market? How can you... Is there any...
Well, there's the opportunity to lose a phenomenal amount of money.
Yeah, but you actually provide the power in the balancing market instead of trading the day ahead.
Yes, so in the day ahead, it's just a supply and demand curve, and oftentimes system security is not reflected, well, every day system security is not reflected in that supply and demand balance. It's only when you have megawatts that you can actually deliver in real time. But it's not just about energy, it's not about the energy imbalance. There is an opportunity for units to be located in the right place where those megawatts are valued, and that's where we see a lot of correlation between the balancing market drives a lot of capacity market behavior. So there has to be some element of locational signals sent, and it's those locational megawatts that have an intrinsic value maintaining system security that are rewarded in the balancing market. And there is no opportunity to avail of or take those positions in the ex-ante markets as they currently stand.
Okay, any other questions? We have time for a few more. No? Okay, I have a few questions. The first one, so you touched on assetless units in your presentation, but I'd like to know a bit more. Do assetless units provide value in the Irish market?
So it depends. It depends who you're asking. As a person who derives strategies for a thermal generator, I would tend to maybe not agree with the value that is provided. We are a unit-based market. We need megawatts in real time. Every time an asset unit trades happen, they're essentially just arbitraging between markets, and they don't actually ever bring those megawatts through to the system. In Ireland, that's a big deal because we're very small. It's highly constrained. In other markets, assetless units do provide liquidity and assist with price formation. But in Ireland, if it's not a wind asset, then there's stripping benefit that potentially could be achieved by a thermal unit that is actually resulting in system security in real time. So ultimately, it'll be the consumers of Northern Ireland and the Republic of Ireland that pay for this liquidity, rather than paying for system security.
Okay, and I have one more cheeky question.
Okay, right.
And I don't want to bring it up so early in the conference.
I think I might know what this is.
Yeah. Dare I use the word Brexit? And what impact could this have on the Irish electricity market?
So, yeah, who knows is probably the first answer. But yeah, we are the single market of Northern Ireland and the Republic of Ireland, so we operate in the UK and Ireland. It's been a poster boy of cross-border cooperation, this ISAM project. The markets are too small on their own to exist in any sort of efficient way. So both governments in Dublin and London and in Brussels have reaffirmed their commitment to maintaining the single electricity market. But if a no deal actually transpires, one of the main drivers for the integrated ISM market was to increase our interconnection with our partners in GB, and that's achieved via the day-ahead market. If there's a no-deal Brexit, then we lose that interconnection from the day-ahead market. They basically just switch it off in the algorithm, so that means that there'll be a high degree of price divergence between the SEM and GB, and that will be a big concern.
Thank you.
Thank you very much.